Hello everyone. Okay, so this question 12 from the 2023 Junior Circle exam, is a bit of a funky one. It's a bit of a funky question because it is a construction. It's a construction question, but it doesn't tell you it's a construction question right away. So you need to know your construction. So you need to know how to construct a perpendicular bisector of a line or bisecting an angle. You need to use one of them two constructions for this one. And then finally, for the last part, you needed to know how to find the length of a arc of a circle. So let's just continue on here. So the diagram below shows the curved shape ABC. Grand. C is the center of the circular arc from A to B. Yeah. A is the center of the circular arc from B to C. And B is the center of the circular arc from C to A. So this is a very tricky part a lot of people didn't really cop onto, really. Is each of these points corresponds to the center of a circle that would make that arc like this. We actually have a segment of a circle here. So we actually have three segments of a circle. So A would be the center point for this arc BC here, if it was a circle there. So you kind of get the gist of it there. So it's all pizza slices. But anyway, we'll be using that information shortly. So the dotted triangle ABC is an equilateral triangle. That seems like very important information for me, because an equilateral triangle, that tells us each angle is 60 degrees and also each side is equal. So using a compass and a straight edge, construct one of the axes of symmetry of the curved shape ABC. Show all your constructions like clearly. So I'm not gonna I can't really show you how to do the construction properly like this, but I'll show you kind of the method for doing it. So you needed to you could have bisected the angle, or you could have found the perpendicular bisector of one of these sides. Because just by rough sketch, we know that this would be an axis of symmetry. This would be an axis of symmetry. And this would be an axis of symmetry. So it has three axes of symmetry, but we only need to draw one. So what we know about an equilateral triangle is, right, the perpendicular bisector will actually bisect the angle as well. So I'm just going to use the perpendicular bisector one, so you know the drill. So it says use your compass and a straight edge, so you cannot just use your set square for this. You have to use your compass as well. So you set it up, you draw your arc down here, ding, ding, ding. Then you set it up, and then you draw your arc again, ding, ding, ding. See where they overlap, and then you're going to take out your ruler. You take your ruler and draw a line. And there you go, there's an axis of symmetry done, right? Or what else you could have done is if you found a perpendicular bisector, that would have worked as well. Right, let me see if we can make that a different color. No. Right, or if you found, not perpendicular bisector, if you bisected the angle, that would have also worked as well. Right, again, this is just a rough sketch because I'm doing it on a iPad, but you kind of get the gist. So there's my axes of symmetry there. We only have to draw one. And I imagine if you just drew a line, you probably will get like 6 out of 10 marks anyway. So I wouldn't be stressing too much. Right, BI. Write down the size of the angle ACB. So they're looking for the angle ACB. They're looking for this angle here. We want to find this angle. Well, what do we know? We know it's an equilateral triangle, so each angle is 60 degrees. That was a nice, easy question they gave us. Gorge. And now finally, find the length of the straight. The length of a straight line segment is 40 centimeters. Find the length of the circular arc from B to C. Give your answer in centimeters corrected to decimal places. So, as I was saying above there, you have to think of it as a pizza slice, right? I now have a section of a circle. So the blue part is a section of a circle of 60 degrees. And we are looking for the length of B to C. We're looking for this. Right, so how do we find that? Well, we use our length of an arc formula, which is the number of degrees the sector is over 360 times pi or times 2 pi or, right? That is the length of an arc. So we need my radius. My radius is actually going to be 40 centimeters, because if this is the center, right, of the circle that which drew the arc AB, therefore this line here will be 40 centimeters. So I'm going to have 60 over 360 multiplied by 2 pi times 40. It says give your answer correct to 2 decimal places. So 1/6 times 80 pi is going to be equal to 41.887 centimeters, but then to 2 decimal places, it's 41.89 centimeters. And that's our answer for that there. So the length of the arc of one of these things is 41.89 centimeters. Right, and I hope this helped somewhat, and I'll catch you guys later. Bye.